Hello friends, this video on solutions part 6 is brought to you by examfear.com. No more fear from exam. The next way to define concentration is molality. Molality. Now the question is, why should we even go for molality? Because we have so many ways to define concentration, right? If you talk in the moles term also, we have moles fraction, we have molarity. And as I told, molarity is very important. So why do we need molality? First, let me define molality and then I'll tell you why molality is required. See, molality is nothing but moles of solute per kg of solvent. Let me write here. And it is denoted by small m. Small m. Moles of solute per kg of solvent. So if you see, there is a difference here between molality and molarity. See, in case of molarity, we have here volume of solution, but here we have solvent. Please note, in almost all the concentration we are using solution in the denominator. Only in case of molality we use solvent here. And there is a reason. First thing, why molality is better, because we are using kg, that is the mass of solvent. Correct? Since we are using mass of solvent, it will become temperature independent. Correct? So it will not be a function of temperature, alright? It is not function of temperature. That is one good thing about molarity. Correct? Also, molality, when you say, if you see, since you are saying it is for the solvent, even if you add more solutes, it's all same. Anyway, we'll discuss that in the next slide when we compare molality and molarity. The most critical reason why we came with molality is, since it is in kg, so it is temperature independent. Correct? Also note that for a very weak or dilute solution, let's say dilute solution at STP, the molality and molarity is almost same. Capital M and small m almost same. Why? Because see, if you see the difference, actually, if you see the molarity difference, molarity is what? Moles of solute by volume of solution. That is nothing but volume of solute plus volume of solvent. But if you have very weak or dilute solution, volume of solute will be very less. So the volume of solution will almost be equal to volume of solvent. And if you take water, for example, this is for water, aqueous solution. Since it is aqueous solution, the volume and the mass is almost same, density is almost 1. So that way this statement will hold true. We will discuss this in the next slide. Just understand what is molality now. So it is defined as moles of solute per kg of solvent. Correct? If you want to find the molality, then give the formula. Molality, small m is how we represent it. You find the moles of solute, you divide that by mass of solvent. Repeating here once again, in kg. It is solvent here. Correct? It is not the mass of solution. Okay, let's understand why molality is better than molarity. Okay, there are so many reasons why we choose molarity over molarity. First thing is, it is easy to measure. Easy to measure. What is easy to measure? Molarity. Why? See, molality is what? let me first write the formula for both. Molality here is nothing but capital small m is equal to moles of solute by mass of solvent. What is molarity? Capital M is nothing but moles of solute by volume of solution actually. There is a difference. Here we have solvent, here we have solution. Here we have mass, here we have volume. Other things are same. So now if you talk about molality, if you want to find the molality, before you make a solution, just measure the mass of solute, mass of solvent, that's all. Because moles of solid is what? Mass of solute by molar mass. Molar mass is something you know. For example, if you are taking solid as sodium chloride, you know the molar mass of sodium chloride. If you are taking solid as carbon dioxide, you know the molar mass of carbon dioxide. That is something you know already, right? You can get it from the tables. But the only thing you have to calculate is the mass. So if you want to find the molality, just before preparing solution, to just weigh the solute and solvent. That's all. But if you want to find the molarity, you have to weigh the solute first, and once you make the solution, you have to find the volume of the solution. Correct? So that is little. It will take a little more time. So this is molality is a little easy to measure. Correct? Also, if you see molality is not function of pressure or temperature. So pressure or temperature. So when you are measuring molarity also, since the molarity varies with pressure and temperature, you have to specify pressure and temperature also. That's again a big headache. But since molarity is, here you have mass, and mass is totally independent of pressure and temperature. So molality is independent of pressure and temperature. So you don't need to worry about pressure and temperature. Correct? This becomes free of pressure and temperature. So that is again an advantage, right? The more you become free of parameters, the better it is. Second thing is, why molality is better? Because in chemical world, mass is more relevant. Why I am telling this? Because see, in chemical world, if you have any reaction, for example, C plus O2 is equal to CO2. So I say 1 mole of carbon dioxide reacting with 1 mole of oxygen to give 1 mole of carbon dioxide, right? At the molecular level, I'll say 1 molecule of carbon reacts with 1 molecule of oxygen to give 1 molecule of carbon dioxide. But since number of molecules are tons, so we have this moles, concept of moles. Mole is nothing but 6.023 into 10 to the power 23 particles, right? So, and I can say that 1 mole is nothing but 12 gram, right? So this is nothing but, if I say 12 gram of this, right? So moles are directly proportional to weight, not volume. Correct? So chemical reaction occurs in the proportion of mass, not volume. So that's why I'm saying mass is more relevant in chemistry than volume for chemical reaction. And since molality is based on mass of the solvent, it is a better choice. Correct? The fourth thing, if you have, let's suppose, I'll take a scenario, right? If you have normally we are talking about the binary solution where you have 1 solute and 1 solvent, correct? But in the real world, we don't have binary solutions that much. We have solution which have more than 1 solute, right? 1 plus solute. So there, if you talk about the molality, so for example, I have solute A. Let's suppose I have solute A, B, C. Example, in this case, let's suppose water is my solution. I am not showing any water molecule here. My solution, and there are 2 solutes. The one in red is A and the one in the blue is B. There are 2 solutes. Correct. Now if we talk about the molality, so the molality of solute A will be independent of B. Similarly, B will be independent of A. Why? Because when we talk about the molality, I am talking about, for example, molality of A will be what? Moles of solute A divided by mass of solvent. Solvent here is water. The molality of B is nothing but moles of solute B by mass of solvent. So if you see here, they are both independent. But talk about molarity, the volume of solution comes, right? So in the volume of solution, A and B both contributes. So one good example is, for example, I have a solution. I have solvent, water. I have water here. Correct. I have water here. And let me add a solute A and let solute A be NaCl. I find the molality of NaCl. And let me then add, after NaCl, let me add some solute B and let this solute B be sugar. And now if I find the molality of sugar, but the moment after I add sugar, the molality of A will not change. Correct? Even if I add some third solute C, let's suppose if I add third solute C, let me add some iodine drops. So even if I add third or fourth solute, the molality of NaCl will not change. The molality will not change, but the molarity will change, because the molarity will depend on the volume of the solution. So if you add more solutes, you may be changing the volume of solution, but molality will not change, because the molality is independent of volume of solution or the mass of solution. It is dependent only on the mass of solvent. So mass of solvent will be same even if we add more solutes. Correct? So if you have one big one solution, you add the solute, find the molality of solute, you add another solute, the molality of the solute A will not change. But the same thing you do, you have this solution, solvent actually, add a solute, it becomes solution. You find the molarity of A, add another solute B in a big quantity actually, and then you find the molarity of A, it will change. Because the molarity of the solution or molarity of the solute is dependent on the volume of solution. The volume of solution changes. Correct? So it's a big advantage actually. The advantage is that if you have more than one solute, the molality of solute or molality of solute A is independent of molality of solute B. Correct? That's a big advantage. This is the advantage of molarity over molarity. Let's take some numericals on molality now. So we have to find the molality of 2.5 gram ethanoic acid in 75 gram of benzene. So I have benzene here. So let's suppose this is my benzene. Blue is my benzene. And the red one is my solute, that is ethanoic acid. Correct? So here first find which is solid, which is solvent. This is 2.5 gram, 75 gram. Also we know benzene is a good solvent. So benzene is my solvent. And ethanoic acid is my solute. Correct? This is done. So now we have to find the molality of solution. So molality of benzoic acid is nothing but small m moles of ethanoic acid, moles of ethanoic acid divided by mass of solvent. Solvent is what? Benzene in kg. So we need to find these first. And this is my equation number 1. So let's find these values. So moles of CH3COH is nothing but mass of ethanoic acid, by molar mass of ethanoic acid. So what is the mass of ethanoic acid? 2.5 grams. Please put the note this one units here. What is the molar mass of ethanoic acid that we can find? If you want, you can do it on your own. It will come out to be 60 grams per mole. You put carbon as 12, hydrogen as 1. 1 into 3 is 3. Plus again carbon as 12. Here 2 oxygen, 32, and 1 hydrogen. You add this, you will get 60 grams per mole. So if you solve this, you get 0.417 mole, right? Gram cancels and mole comes out. This is my moles of ethanoic acid. This is I know. What is the mass of benzene? Mass of benzene in kg. So we have 75 grams. 75 grams means 75 by 1000 kg. So let's plug all these values in this equation 1, right? So if you put these values in equation 1, the equation 1 becomes M becomes moles of CH3COH, that is 0.0417 mole, by this in kg, that is 75, and this becomes. To solve this, you get 0.556 moles per kg, or you can also say 0.556 small m, and that is my answer. Pretty easy, right? You don't have to find the whole mass or the volume of the solution. You just have to find the mass of benzoic acid, in fact benzene. That is my solvent. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.